Hello all, I hope you are having a good day today. And today I will be talking about how to design database platforms step by step. And in the end, we will understand which problems that Temporal solves. And I am sure that while iterating our design step by step, we are going to have much fun. And I need to get this one. And before continue, let me introduce myself quickly. My name is Mehmet, and I am living in Ankara, Turkey. And I have been working in Trendyol Group almost 4 years as a senior software engineer. And I am mostly working on database and database internals. I am author of some open source projects, such as Concurrent Service Map and GoDCP. GoDCP is a change data capture client for Couchbase that we developed in Trendyol and made it open source. If you are interested, you may take a look at it. And I have a website that I share my travel photos in it. And lastly, in my spare time, I love playing piano. Let's continue. Before designing our system, our platform, it is important to understand what is the reconciliation process and reconcile loop, same meaning. If you worked on Kubernetes custom resource definition before, you may have heard it. But I just want to show it to you with an example. Let's say we have a developer need a database, of course with configuration as well. This need will be desired state for us. And in the next slide, this slide will be very important. Our platform will sit between desired state and current state. And our platform's one of the main responsibilities is observing the desired state and adjusting the current state. This is actually how most of the cloud providers work today. And in our use case, desired state is a database need. And our platform will check current state, and there is no database for our infrastructure right now for that user. This means that our platform needs to create a database to be able to keep sync desired state and current state. And today we will be focusing on this use case, database creation, instead of other use cases of database platforms. Before designing our system platforms, first we need to define our requirements. Our first requirement is database creation. If there is any problem in our infrastructure, what kind of problems, timeout problems, disk problems, etc., our database creation may take weeks. And I need to say that user experience is one of the most important topics in platform engineering world. Our customers, which is developers by the way, developers should trust our platforms. They gave their desired state to us, and eventually they know that they will be able to get their database eventually. Eventually is a very special keyword in platform engineering world, and we will be talking about it in the next slides. And our other requirement is we need to be able to create two database instances in the different regions. And in the next slide, we will be seeing why we are doing that. Our other requirement is replication. Replication is one of the most important topics of database internals. It provides some opportunities such as durability, and high scalability. And most of the time, we are forgetting the scalability opportunities of replication. And I want to try to show you with an example. In our use case, we will create two databases in two different regions. One will be in Istanbul region, which is a city in Turkey, and other one will be in Ankara. And we will set up replication between these two regions. And let's say there is a problem in Ankara region. We can still use Istanbul region database as a primary database. Of course, this depends on your replication configuration, but it is not topic of today. And for scalability perspective, let's say we can spread traffic for two different regions. For example, our pupils lives in Istanbul can connect to Istanbul database, and our pupils lives in Ankara can connect to Ankara database at the same time. In this way, we can use two regions at the same time, and we can increase utilization as well. And we have some requirements for replication, of course. We need to be able to create replication between two regions. This is the first requirement. Our other requirement is, and I think this one is very tricky, we need to wait until two database clusters are ready to use. But what we talked before, database creation may take weeks or days, doesn't matter. And we need to wait. And we are going to see it, how can we implement this. And our last requirement is resilience, of course. We already talked about it, but I just want to mention it again. Our system, our platform should solve almost every problem. At least it can try. And eventually, we need to give database to our customers. Now, we know the use case, we know the problem, we know the requirements, but how can we implement database platform? This is actually where fun starts. Let's code. I will start with traditional programming way, traditional programming design, and I won't use any technology in here. No Temporal, no Kafka, just pure Golang. And I want to say that if you don't know Golang, don't worry, because I try to keep every function of mine very simple. And actually, I couldn't see. My use case will start from create multi-region database and function. And in this function, I call create database function for Ankara and create database function for Istanbul in two different coroutines. This means that this function will run parallel because I call them in different coroutines. And I will wait results of them. And if there is no problem, I will call create replication function. And you may say that there is no problem in this system, but of course, there are some problems. Our first problem is, what we said before, database creation may take long time, days, maybe weeks. How can you block a function call for 1 week? You can try it, but most probably you cannot do it. Our other problem is, what we talked before, user experience is very important. We cannot show every error to our users. At least we need to try to solve or retry the problems. But in this design, we couldn't. Now, we understand that we cannot solve these problems. Maybe we can, but it is very hard to solve that problem by not using any technologies, I can say that. And let me introduce to you a new technology, Apache Kafka. Apache Kafka is an event streaming platform that we widely use, in Trendyol group, we widely use Apache Kafka for both data pipelines and event-driven system. You can produce, publish, or consume message by using Apache Kafka. I put a picture in the right side. There are microservices, order microservice, payment microservice, product microservice, maybe warehouse microservice. And they can make communication by using Apache Kafka, asynchronously, of course. Let's say a customer gave an order, and my order microservice will create order is completed event and publish it to Apache Kafka. And payment team can consume these events and start the transaction of payment processes. And payment microservice send another Kafka event, payment is completed. And maybe warehouse team, warehouse microservice, can listen, can consume these events, and they start shipment. And this is actually how basically we can implement event-driven system by using Apache Kafka. Now, here's the code. I have still create multi-region database. My use case will start from here, create multi-region database. Now, I am calling Kafka publisher.send function. This will send a Kafka event to Kafka cluster. I will send create database event for Ankara and create database event for Istanbul. And that's it. My use case function will be stopped here. And I have in next function, I have a consumer that consume create database event in the Kafka side, of course. It takes region as an input. And as you can see, I try to write a command line database creation in here. I mock the database creation. But in the next slides, we will be able to talk about how can we implement database creation as well. And let's say database creation is completed. And now we will send another event to database Kafka, which is the database created event. And as you can see in the top one, there is a database created consumer in this time. This function, this consumer, listen database created consumer this time. And in this condition, this function, this consumer, is going to check if all regions are ready to use. If they are ready to use, I will create replication between these two regions. I'm sure that you are seeing most of the problem here. Let's talk about it. This code actually won't work in Golang. I just wrote a pseudocode. To be able to support this behavior, you need to store your states. What I mean, let's say there is a problem in Istanbul database. And there is no problem in Ankara database. Ankara database will be created immediately. But let's say Istanbul database will be created in 1 week later. But when Istanbul database is created, we need a way that we need to understand Ankara was already created or not. To be able to support it, we need to store this information, these states or these events in the persistent layer database or etc. And our other problem is race condition. If we consume same events at the same time, for example, Ankara and Istanbul were created at the same time, and we listen these events at the same time, and Ankara will check is Istanbul ready, and Istanbul check is Ankara ready, and we couldn't create replication. And in the end, we will have two healthy database clusters, but there is no replication between these two databases. But of course, this problem can be solvable, but should we solve it? We will see it in the next slides. Other problem is Apache Kafka does not have built-in error, retry, or delay features. We need to write our own mechanism. And I can say that we widely use Apache Kafka in our production environment. It is very hard to implement this error management. And other problem is we need to manage Kafka components. We wrote Kafka consumer, Kafka producer, but if we configure it wrongly, we can miss some events. And in this way, it can affect your business, your use case. And last problem, I think this is the most important problem in this system, is cognitive load. Cognitive load, I think, is very important. Basically, cognitive load means that how much a developer needs to think to understand my use case. And as you can see, this code is a little bit complex. Understanding the business by just following the code, almost impossible. In the real world, in the enterprise world, in the production, in company world, I can say that, my consumer, my producers, my use case function will be separated in different packages, different folders, different files. And understanding the business by just following the code, almost impossible in enterprise world. Now, let's forget code. Let's forget Golang. Let's forget Kafka. Now, I want to introduce to you business process modeling notation. Now, we will look at our problem from different perspective instead of developer perspective, which is a BPMN. BPMN is basically a flowchart method that visualizes our use case from start to end. Very basic flowchart method. It starts with an event and ends with another event. And my use case have some activities. Activities are very important in here. Everyone in the team should understand same meaning when they are looking activities. Business team, product manager, backend, frontend, mobile team, doesn't matter. Everyone should understand same thing when they are looking at activities. And in BPMN, every shape has a special meaning, but it is not important. It is not topic of today. You may look at it later. And this is important. I am calling always all use case, but from now on, I will call as workflow. This is a example workflow of BPMN. Now, let's draw BPMN diagram of our workflow. What we are doing, first, developer needs a multi-region database. This is a start event. And there is a parallel gateway, but it is not important to know that. And Istanbul database creation activity and Ankara database creation activity will run parallel. And I will wait the result of these activities. And finally, I will run create replication activity, and it will be my end event done. As you can see, there is no race condition check. There is no state machine. Business does not care anything about your solution. This is the business, actually, basically. But I know BPMN. I know the business problem. And how can we implement BPMN to our application in our code? This is actually where fun starts, I can say that. Temporal is an open source workflow orchestration platform. And Temporal provides state persistence, built-in retries, delays, and long-running tasks, which is the most important topic while creating database platform. And it supports different programming languages. Deploying Temporal server is very easy. Also, you can use Temporal Cloud as well. You just need a database to be able to deploy your Temporal server. We are using PostgreSQL, for example. And this is important. You are writing your workflow and activity code inside your application. You are not writing any code to Temporal. I think this is very good, I can say that. Let's change our design by using Temporal. And as you can see, I have a create multi-region database function, still same function, but now it takes workflow.context. This means that this function can be used as temporal workflow as well. And in the next line, in the first line, I call workflow execute activity, create database for region Istanbul. And the other line, I will call for Ankara as well. And I will wait the result of this database creation, and then I will create replication between these two regions. And I need to say that built-in behavior of temporal activities will be retried your activity infinitely, but of course you can configure it. Also, Temporal provides an UI for us. We can visualize our workflows. Let's say we created a workflow for database 123, and database 123 create a two activity, create database, one for Ankara, one for Istanbul. And when two are completed, I will create another activity, create replication activity. And we will debug how temporal works, how temporal replay works in the next slides. But before understanding replay, first we need to understand temporal states. Temporal has different kind of state, but basically we have 4 states: scheduled, started, completed, and failed. Scheduled means that it is ready to process. Worker, I mean our application, can poll and start execution of my activity. I have started, completed, and failed as well. Execution completed, started, and failed. Now, from now on, we will be talking about how temporal works actually. Temporal creates an event history per workflow execution. And what is event history actually? Event history is a log of all events that happened in the workflow execution. And in the later, temporal will use this event history in replay state. We will be talking about it. In the first line, I call an activity, create database activity, which is cause an event, adding an event to my event history. Activity task is scheduled. And in the next line, I will add another log to my event history. Actually, temporal will add it, of course. I will schedule another activity, which is create database activity. In the next line, this line is very important. My execution of code is stopped in here. And if there is any addition to event history, replay will be triggered. And my workflow execution will start from beginning. But I just want to mention one thing. In temporal, there are some performance optimizations, such as sticky execution. But let's forget them. Let's think about we are disabling the sticky execution to be able to understand how replay works. Now, our code stop execution, and we are waiting until there is a new event in the event history. And as you can see, activity was pulled from a worker and started and completed, and our database creations now are completed. Now, now we can see temporal event history as a basic table. Now, because there is a change in the event history, replay will be triggered. Replay will start running your workflow from beginning to end. And it will start from our first line. And temporal, by using event history, temporal knows that I already run this line. And it will skip. It will skip. It will skip. And it will skip. In this line, create replication activity, temporal checks event history, and there is no log for create replication. This means that temporals run this workflow, this activity, sorry. And activity task scheduled, started and completed. This means my workflow is completed right now. If you compare temporal design and traditional design, as you can see, they are very similar to each other. And I can say that both of them has very less cognitive load, because every business can be understandable by just looking at a function. Now, we didn't solve every problem. What we told before, database creation still can take a long time. And the other problem is, we talk about it creating multi-region databases. But let's say our business wants to another use case, and we need to be able to create single region databases as well. But because we define create database as activity, we cannot call it outside of workflow. Now, I changed our design a little bit. Now, our create database is a workflow instead of activity. And in my main use case function, actually there is no much change. Instead of workflow.execute activity, now I am calling workflow.execute child workflow for create database. And then I am waiting execution of create databases, and then I will create replication. Create database workflow is very new in this design. Create database function have a variable, max retry variable, and retrain interval variable. And in a for loop, in every iteration, we will be checking if database is created or not in this function. And I wrote a small logic in here. If attempt is equals to max retries, I will return true. I just try to mock database is created. And if it's created, I will return nil. This means there is no problem. I already created my database. But if it's not created, I will call workflow.sleep function. This is a very special function that's coming from temporal side. And we can wait our workflow at least this retry interval, we can wait 1 second, we can wait 10 seconds, maybe we can wait 1 year. It is not important. But in our use case, we will wait 1 second to continue to next iteration. Now let's look at our temporal UI for this kind of workflows. And database 1, 2, 3, now it creates two child workflow. And when two child workflows are completed, I create replication activity. And if you look at a child workflow details, you will be able to see, we will call first check if database is created activity. If it is not created, we will wait 1 second. And we will check it again. If it is not created, we will wait another 1 second. And the last attempt, we wrote that logic. Our function will return true. This means database is created. This means our workflow completed. Let's change our implementation. Now, check database is created function will always return false. In this way, child workflow, create database child workflow, will try at least 3 times, but couldn't create the database, then it will return error. This very depends on your business, actually. Most of the time, maybe you want it. You can try to infinitely retry it, but it very depends on the business, actually. And this is today. If you have a question, you can feel free to ask.
Questions? Yes.
Hello, thank you for the talk. What makes database creation take weeks? Are you using a cloud provider for your databases? And
No, actually, we are using Terraform. We have our own data centers. We are using Terraform. If there is a problem in Terraform site, this is actually worst case for weeks, but most of the time, it may take 1 day in the worst scenario.
like 1 day, and like because with Terraform you'd create, you'd have the apply taken a day. Is that what you were referring to?
No, actually, if there is any problem in data center site, for example, network problem or disk problem or node problem, and if they don't solve the problem, we cannot create a new databases until they are solving that problem.
But the actual process of creating the database doesn't take.
No, it doesn't take getting error if you are asking it, because Terraform will retry it infinitely. There is a state machine in Terraform as well. We are trying to replace Terraform by using Temporal. I think you were talking about it.
Yeah, I was just curious how it can take days. That was the main question. Yeah.
It depends on our infrastructure.
Okay. Thank you.
No, you're welcome.
Thanks for the presentation. This database creation we can consider is a long-running activities. Is your activity auto-resumable in case of any failures?
Actually, we are trying to write all our activities idempotent. We can call our activities again and again without any side effect.
But is it auto-resumable? Say after 50% of the process, you face some error and activity, the database creation activity fails. Then is it possible to start from where it failed, or it has to be started from the beginning?
In our workflow you are talking about,
yes.
Right? You can continue from where it get error, because Temporal used event history to be able to know where it stayed.
But say like 50% of the database creation is done, so like I assume it creates some database objects, entities, etc.
I understand.
Yeah.
Sorry. And you are talking about this function actually. This function, right? Check if database is created.
Yes.
Let's say you are using a virtualization technology such as Terraform or different technologies. You are sending a request to Terraform if it is ready or not. You are not retrying to anything in here. You are just checking third party. Or for example, let's imagine that you are using a cloud provider, Google Cloud or AWS, and you start the execution. And you can check it in special intervals.
Sorry, one last thing. So
Yeah,
would you consider of returning or using kind of heartbeats from the activities to check the status?
Yeah, but in this case, this function, for example, we are not managing the Terraform. And we cannot implement that heartbeat in Terraform site. But if we manage the Terraform, or if we have our own infrastructure provisioning thing, we can implement heartbeat. This is the, I think, best solution. Because this is, I think, not very good solution because in some interval, you need to check every time, check. But as you mentioned, with heartbeat, it will be better solution.
Any other questions? Okay, thank you.
Thank you.